Welcome everyone, this is my talk on voltage drop. I've come across issues like this in the past, so I thought I'll just share some of these experiences and give a little talk. So as you can see, my aim is to basically help people with a bit of information so they're armed with some knowledge when they go to buy cables or fix a issue up. First off, a few quick explanations around electricity. As you can see, the first one there, volts. It's really just measuring the force of the electrons behind a say a battery or something like that, and it's equivalent to, say, the force behind a dam. The higher that dam, the greater the force of the water, the deeper the dam, and the bigger the battery voltage, the more force behind that battery. Now, the electric current is the movement of the electrons through a conductor or through a circuit, and we measure that in amps, and the resistance will slow that current down. So something that's, and we measure it in ohms, but it's not really important in this context. Just realize wires have resistance, unless it's cooled to absolute zero, and it's equivalent, that resistance is equivalent to, say, restricting a flow in the water pipe. The thin pipe slows or resists the water flow. Things to note: the greater resistance, the greater the voltage drop. So the way to reduce that voltage drop is just basically reduce the resistance. So shorter cables or thicker wires. The thicker the wire, we're just talking copper, I'm not talking changing different conductor types, but the thicker the wire, the less resistance, and the shorter, the less resistance. So too much voltage drop could result in the equipment just not getting enough current, not getting enough electricity. So I'll show you later some, if you look at the specifications of some of your equipment, it might only operate at 11 volts. And if you have a 12 volt battery and 1.5 volts drop in the cable, that bit of equipment's not going to get enough current or voltage, or both. So the way you measure the voltage drop along the wire is just basically measure the voltage at the start of the wire, measure the voltage at the end of the wire, and subtract them, and that's your voltage drop. And I plucked an example out of the QHY manual, and you can see there's a manufacturer specifying between 11 and 13.8 volts, and it's a couple of little notes about not long cables and about voltage drop, and some formulas which you can go into if you want, but that's an example of watch out for the voltage drop. Now, I've plucked some specs out of some of the gear I've used, and here's some examples of, say, a mount. There's an EQ6 round about that 4 amps. Jump down to some of the cameras, you can read there for yourself. A bigger camera, say round about the 40 watts of the QHY 600, and you can see the current of the mount or the camera. They're probably your biggest users, followed by, say, a big dew heater. And I'll put a little note down the bottom what power is. It's basically just the volts times the currents, and it's measured in watts. Now, to measure the voltage in the circuit, you use a multimeter. There's a couple of different type of multimeters. You might find troubles measuring the current in a circuit if you use a multimeter where you have to insert the meter in series with the circuit. So this is where a DC clamp meter comes in handy. Now, a cheap clamp meter will only do AC, but a more expensive one will also do DC. Now, I have an example that's it's already pictured, but a clamp meter, you can see just it just clamps around one of the conductors of the wire, or if you're going to measure voltage, it also has a voltage probe. Now, how do you measure around wires?
Can I just ask a question?
Yeah?
So when you clamp it, you have to have a bare wire to clamp it?
No, it doesn't have to be bare.
Okay.
In fact, it's just induction around the cable. But what you can't do is you can't clamp it around both wires. You've got to clamp it around one. I always do the positive to be consistent. So what I've made,
You're putting it around. You're not actually pushing into the wire.
I've found it says, I think in the book, to try and keep it in the middle, but I found it makes little difference. I just clamp it around the wire.
No, I was thinking that you actually clamp the wire in.
No, you don't clamp it in, no. You clamp it around. See, there's a hole,
Right.
and you clamp it around the wire, like that. Now, what I was going to point out is what I've made, let's put me back in focus, is two little short bits of connectors. Now, you can see in the case of most astronomy gear has these barrel connectors. Now, a thing to watch with barrel connectors is these particular ones, most of them will have the center conductor will be 2.1 millimeters. You can get 2.5. And if you use a cable with say a plug with 2.5 millimeter hole, and you use that to plug into the back of your camera, you're going to get a loose connection. So that's the first bit of resistance. You don't want a 2.5 center, you want a 2.1, and the best way to test that is just have a 2.5 connector. And I found sometimes your laptop will have a 2.5 center, and if you grab one of these connectors and you can't plug it into the side of the laptop, with no wires connected, then it's a 2.1. If you can plug it in, then it's probably a 2.5. So
the Meade LX90 had a 2.5 power inlet to the mount.
Yeah, well, so know you're connected. That's the clue.
Yeah.
A lot of the ASI, the QHY has the 2.1. So I made up a short cable, male and female. So I can plug this in the back of the camera, for example, and plug the lead in there, and I've got access to measuring the current. But I've also got access, what you find is I've scraped the plastic off, won't focus, off 2 points here, and they're separated. Where my two fingers are, I've scraped the plastic off. So if I squish the wire together, I can't short it, but I can clamp a voltmeter around that wire. So I can both measure the voltage and the current of the particular circuit in test. And because I use power pole connectors, I've also done something similar with the power pole, except I don't want to measure the voltage there because I can measure the voltage on the fuse or something, but I can clamp the current. So a couple of these short little connectors is quite useful. So really, to measure you don't really need an ammeter. That's just to give you an idea of what type of current's in your circuit, but it is handy to know. The key thing is the voltmeter. And you'll find troubles, unless you make yourself up a little cable, like I said, you won't be able to measure your voltage at your camera or at any other device. If you just need that little test, that little jumper cable, and that will really help you out. So what I did,
Can I just make a point?
yes,
I think you need to spell out the fact that that clamp meter will not interrupt the circuit, but if you use an ammeter, you're putting the ammeter into the circuit.
yes.
So this thing's measuring out kind of like, let's just say by magic.
Yeah, I've kind of listed it there,
Yep.
but you're dead right. The way you measure current, normally voltage is, it's like the pressure. So you don't really, you can imagine this as a pipe. You really only have to measure the force against the electricity force. So the voltage can be measured without anything hanging off the end. You don't need a camera or anything. Nothing hanging off the end, you can measure this voltage. But the current is the flow of current through to the camera or whatever device and back again. Now the only way you can measure current flow is to sit in the circuit. So you can imagine the risk to your gear if you had to break this apart and put your probe in there and power everything up and you knock it off and the probe drops and things fall off and things like that. It's just not a good way to do it. So the clamps across, as I've shown, the cable, and it's all currents have a magnetic force around, has the current flows around the wire, and all it's doing is it's a scale measure. It's like measuring that force has the current flows. So if there's no device connected, then there's no current flow and it'll read 0, even though the volts will read your 13.1, 13.8 or whatever the voltage is on the other end of this cable. Okay? So that's a good point. The ammeter or amp meter, because we're measuring currents, is best measured with a clamp meter. And because most cables are like twinned and joined together, the easiest way to do it is to have some little breakout and to test different cables. Now this is handy, having that little breakout, because what I did is an experiment, and I'm going the wrong way now, an experiment, and I measured a bunch of cables. Now to do that, you can see I built myself a little dummy load and I plucked round about the 5 amps out of the air. You saw some of the examples, and out of curiosity, there it is. It's just a little bunch of wire wound resistors paralleled up with a connector on the end. So I made myself up a little dummy load. I put the meters around it. I've got 2 meters. I've got another voltmeter and I clamped it around. You can see I've clamped around those bare wires of that little connector, and I was measuring the voltages. So if you want to do the test yourself, if you want to just test your cables, make yourself one of those little wiring things and just use a multimeter. But if you want to have an idea of what all the current's been used, then use your clamp meter, because your clamp meter you can then test individual, and really the big ones are going to be the motors, particularly when they're slewing, the cooling on your camera when it's in its cooling mode, and a big dew strap, particularly if you've got the variety where you've just switch it on. If it's one of those dew controllers which are controlled by the dew point, then it's not going to be turned on very much unless you have humidity and temperature which drops below that dew point. So this is my test, and you can see I've picked a number of cables there, and of those cables you can see there's a significant drop in the thinner cable down to 3.36 volts drop. So if you had that thin cable connected up to the mount, you'd have variable problems. You'd have intermittent problems. It really would be dropping even at 13.5 volts. Yeah, you'd be on the borderline. And if your battery was only a lead acid, it was down to, or really any battery, down to 12 volts, and you had even cable 5, you'd start to have troubles. So really, I'm going to recommend only a particular few cables.
What kind of currents were you pulling in that table? I didn't see it.
Okay, now I drop back. It was really around about the 4.7 ohms. In fact, I think on that first picture you might even 4.9.
5 amps.
Yeah, it was around about 5 amps.
Oh, okay. Yeah.
So it depends on, I think the battery voltage was around about 3.1 volts from memory. And your float voltage is going to be 13.8 and could go 14 point something if you're charging it. I only use some lithium iron phosphate, which is a much safer type of lithium battery variety, closer to the lead acid type voltages. So yeah, around about the 5 amps. And if we go back, you'll see, I'm not real sure of the spec. I looked these specs up, and the 294 apparently is about 5 amps. But you know, you can see the EQ6 is 4 amps, and round about the 4 or 5 amps, some of your mounts and your coolers.
Yeah.
So that's why, and I looked at some resistors and found, yeah, that's close enough. I'll get 10 of those. I'm not too, couldn't be bothered too much in working out parallel, and I knew that would give me round about the 2.7. So that's how I did that. So at that 13.1 volts in from memory, you can see 12.8, that's not bad. And 12.4 is fine too. But 11.7 isn't good. And 9.73 is not good either. And you can see the thickness. Now, really, those right-hand cables, and I'll show you some of those in real life in a minute, I pretty well only use cable 1 and 2, depending on the right-hand side, what I'm doing. If I'm supplying a couple of things up to my mount, I'm using cable 1. If I'm powering most things, I'm using that cable 2, and that cable 2 is just what JCAR would call a 15 amp cable. So that's my standard. Now if I'm only powering a little meter or you know, something light, then cable 3 is kind of all right. But you'll find cable 4 and 5, they're like JCAR type cables with a cigarette lighter and a power plug. They're common cables that you might buy in an electronics shop. Even 6 I've got somewhere that's got a barrel connector and a cigarette lighter on it. So these are cables I've had lying around that I've bought somewhere or been supplied, and I've kind of used and wondered what's going on. So this is where, and I knew better, but you still kind of grab and don't think. You kind of just quickly connect something. So now I pay attention. Now I use all power pole and provide good connectors, because as well as the cable, the voltage drop in the cable, you're going to get voltage drop in your connectors, you're going to get voltage drop in your fuses and any switches. So I now choose solid fuses, good connectors, not the cigarette lighters, and decent cable. So does everyone know what I mean about power pole?
Yeah, Anderson power poles.
Yeah, the Anderson power pole. I'm talking about the 1545 amp ones, not the SB50s. Like, you know the difference. I'll actually...
I normally use the 15.
There's an Anderson,
Yeah.
what they call 50 amp SB50s, right? They're fairly common, particularly in the RV caravanning industry. And that's the Anderson power pole. If you look in, they're essentially the same, one's just miniature.
Yeah.
They're both Andersons, are they?
Technically, this one may be. That could be a Chinese copy. This is certainly an Anderson.
And the other one, the smaller one's rated for how many amps?
Oh, I think about 30 amps.
You can get 30 and 15, I think.
Yeah, 30 and 50. And that's really the size of the pin inside.
Yeah.
So, and you can buy those in blocks of 20 and that. There's a Radio Spares in the US actually, which kind of make these cables and all types of things. So you can make cables. If you're a person that makes cables, like I made that, and it's like, I think I purchased this one, and that's the better size cable. You can see the thickness of my thumb that I'm showing, and that came. The reason I purchased that is because I like the way it was made with the thicker cables in that barrel connector. But you can, there's no reason why you can't buy these little screw connectors with barrel and screw the thicker cables in. There's a screw. You're that focus.
The solderable versions of those connectors don't lend themselves to decent...
No, I kind of gave up soldering these thicker cables to the little barrel connectors you get, so I end up starting to use these or buy them professionally like that one I just showed you. So that's your choice on those cables. So what I've basically found is I like the 8 AWG for the, really from the battery to my fuse. I usually use the power pole fuse panels.
Can I just interrupt there?
Yeah.
Presumably 8 is thicker than 16?
Yeah, the smaller the number, the thicker the cable.
Yeah, okay.
Now, you'll see got that 6 AWG. On my battery, I also have a 6 AWG on a 100 amp fuse, and that's for a 600 watt inverter, which I just hang off and drive basically a computer charger and that. They're things I had, but the recommendation for that inverter was 6 AWG with a 100 amp fuse. What I have behind the 8 AWG, 8 gauge, is a 40 amp fuse, and that goes down to a little distribution fuse panel. And I essentially use the 14 gauge for, as I've got listed there, the higher current, which is really the mount or up to the mount, and the other two smaller gauges for lower current depending on what I'm doing. And I thought we can't end something talking about power without chatting about fuses. Now, for those that don't know, fuses protect the cable. So as such, you want that fuse as close to the current source or the battery as possible. And it's basically you pick a fuse for the current. So don't use those blade fuses for 100 amps. Use a MIDI fuse or a buzz fuse or something like that, something with bolts, because they'll just burn out, and they're too high a resistance for those bigger currents. So you pick a fuse so it's small enough to protect the cable, but large enough to carry the load of the that you're driving, and that's really the only purpose of that fuse.
I would say it's there to protect the equipment.
No, it's there to protect the cable. Equipment should have its own fusing and protect itself. You've kind of, don't forget the electricity power starts from the battery. So if the equipment hasn't got any fuse, then fine. But it's there to protect the cable. That's why you've got to have it as close to the battery as you can, because if you put something, if it wears out higher than the fuse, close to the battery, then it's going to blow up your battery or melt something or cause a fire. But the device itself should have its own fuse in it. So, hopefully, any questions? Now,
I just got one. I found the 2.1 to 2.5 mil jack diabolical. At night, it wasn't very easy for me to just look at them to know, and pushing it in and out didn't always work. It was a bit loose. And it actually leads to the fuses blowing, sparking. You don't see the spark, but the fuse blows. You know
yeah.
pretty well in the middle of the night you're changing fuses, and what amperage is that?
You know where I've come. I've had the same thing with the QHY 600. The way it works is that you don't, to reset the USB, you're supposed to pull the power out and put it in. Now I kind of put it in at last. I don't fire it up all at once because you get exactly that thing. But the cameras come with these barrel connectors on the back, and they don't give you the choice of the Anderson connectors. Fortunately, things like the astrophysics mounts and stuff now come with the Anderson connectors, the power pole connectors already. Now here's an example, and it's a bit heavy. Here's my battery, and you'll see, if I turn it around the right way, I have a fuse right on the positive. Two fuses, there's a 100 amp and a 40 amp there. And there's the 6 and the 8. And I also have the SB50s, and that's 125 amp lithium phosphate, but that's what I mean about powering or putting the fuse as close to the battery as possible.
I agree. Nothing directly related to that, but some people may not be aware that you can actually also get little DC mini voltmeters effectively in a little panel, and I'll post a link to what I use, but I haven't paid to the exact connectors I use, because I use a lot of the 2.1s and the RCA connectors when I set up all my time-lapse stuff, and knowing the voltage at the end, it's just really easy to stick something on which is purpose-built and which will tell you the voltage directly without having to sit there and pull out a voltmeter and try to get pins down barrels and stuff like that. So it sometimes makes sense just to have a purpose-built something for measuring the voltage for where you need it if you're breaking stuff and pulling it down.
Yeah, I hear what you're saying. I have a like this little inline voltage current measure with Anderson connectors on it, but I rarely ever use it. My Astro gear I have permanently wired in a little module which I sit on the gear, so it just plugs that in, so I don't really have that problem. And
time lapse, because I'm breaking.
Yeah, you're setting
3 or 4 different cameras and different cables and all the rest of it.
And you've also, sorry, you've also got with the different cameras, you've got different voltages too. I think you've got like 8 volts and things like that. So yeah, I fully see what you're trying to do there. What that battery, by the way, behind me, and if I fire up something, I'll show you. Will I? Yes, I will. Enerdrive. On my iPhone, I can connect to the battery, and it's straight away telling me the voltage, 13.3, 125 amp hour, and if I was using any current, it would tell me that. So that's got that battery has a, there's a few Invicta you can get them, that's a EnerDrive. That's got a state of charge battery, so it basically tells you the current capacity, and you can Bluetooth to your current and voltage at the same time. So they're available too.
That thing is awesome. How much is the other end of that?
It's all built into the battery. So just look up EnerDrive batteries, and I can tell you about that fuse too. It really makes it a tidy unit. You don't have to have any state of charge. It's an expensive battery.
So the Bluetooth device is free, you just have to buy the battery.
It's on your phone. It's just a phone app, and you just have to buy the battery. They in EnerDrive. Let me show you. Oh, it's heavy. EnerDrive. Can you see that? It's a lithium B-Tech. That, by the way, you go and do that to a 125 amp hour lead acid. You're not going to do that.
How much is that battery?
Oh boy, I'd be surprised if it was under 1,200 or something. It's expensive.
$1,200. Okay.
No, it's
And look it up, 1650.
yeah, or 16. There you are. I forget, but it's Invicta is another one, and there's two types of EnerDrives. Invicta. If you've got multiple batteries, you don't need that state of charge all in one. You're better off getting another unit. So they sell them with and without that. But if you're after it, if you don't mind paying for a bit more quality, and these are Australian assembled, that battery or the Invicta, or I think there might even be another one with your Bluetooth to it. So all your state of charge, your current measurement, the voltage, how full it is, you can just do Bluetooth to it in the middle of the night and just see how your battery's going, and you won't have any trouble with 125 amp. I'd be surprised if you
I
did.
reckon you're paying twice the price just for the nerd factor.
Oh no, you're probably paying about a quarter again. But and this is this is prismatic batteries. It's better rated than say one that you might get in Western Australia on the internet.
Low temperatures, that battery.
This lithium iron phosphate, you can't, and they don't have heaters in them in Australia. They do make heaters in North America, like a little heating pads in the battery. But I think from memory, if you have a look at that spec, it'll be something like you can discharge them down -20 or something. They'll operate down -20. But with any of the lithium iron phosphates, I don't know how you go with other lithiums. Do you realise there's two types of lithium? I'll tell you that in a minute. That you don't charge them below zero. So you've really got to have,
Degrees.
0 degrees Celsius.
Right.
So you really got to have, if you're in that type of environment, you have a BMS, you make sure your battery's got a battery management system which has a low voltage cutoff. And because you don't want to charge below, that's on the charging, below that 0. But these are lithium ion, and the active part is the iron phosphate. So it hasn't got the density that your camera battery or your phone battery, but your camera and phone batteries are cobalt based, so lithium cobalt. They usually have a nickel manganese component in there to stop the little dendrites and stuff forming through. But those ones from cameras are much more energy dense, and they're the ones that explode. So these ones don't. You look on YouTube, you'll find people blowing them up and shooting them and all types of things. They're used in the RV industry. They've got a slightly different voltage to the lithium cobalt based, and they're more closer to the voltages of a lead acid, and they don't need the voltage regulation. Find if you're going to get a 12 volt one based on cobalt, they're usually a higher voltage, and you've got to have a 12 volt regulator in them to keep that voltage at 12 volts.
What's the service like for that thing at $1,600?
Okay, I think the depth of discharge, if you look on the battery spec, you'll find various cycle counts. That's charge, discharge, that's cycle based on the depth of discharge, DOD. There will be a DOD figure. Now, if you have a DOD figure of about 80%, so you drop it down to 20%, which lithium iron phosphate's fairly level with that 12 volts, and it's got like a sharp drop off.
Yeah.
You'll probably get round about the 2 or 3 or 4,000 cycles, whereas a lead acid might only be 500. If you only take it down to, and this is the reason why I've got 125 amp hour, because I have had 100 amp hour get to about 30% driving the computer and a few things over the 10 or 12 hours at night, in the middle of winter with the dew controller going. But if you only take it down to say 30% or 50%, you might extend that life cycle to 8,000. So while the upfront cost of that battery by itself is very high, the life cycle over the life of the number of cycles you get and the depth of discharge, so you can have a smaller battery, like 100 amp lithium iron phosphate might be equal to, say, 160 amp in capacity, usable capacity, to 160 amp lead acid. When I say lead acid, I mean AGM, the glass matrix. That's the way it's built, with lead wrapped around the glass mesh or the gel. So both of those are very similar.
What is the life of like the shelf life, and how do you treat it? You have to keep it on trickle charge.
Yeah, you can keep it on trickle charge. Its shelf life, I think you'll find the phone batteries have a slower discharge, so the cobalt base compared to the iron phosphate, but you can also trickle charge them. And I've read a couple of places where some people claim that if you trickle charge these lithium type batteries, you shorten their life. And sometimes I think they're mixing up the grouping the lithium ion together, and not necessarily they're generalizing, because I know you're better off keeping the lithium cobalt base, like your camera battery and phone battery, at probably the 80% as the storage life. Whereas,
so when we say trickle charge, we're not really talking about the old school trickle charge. It's got to have a proper battery management unit on it, right? The lead acid uses about a 7-stage charger. Essentially, it's 3 bait or trickle, the bulk, and it's got an anti-solvation charge at the end. So about 40% of the time you're full charging, then the 60% of the time you're charging the 80% of the voltage to stop that bubbling solvation in the lead acid battery. It's got that curve, whereas on the lithium base, the lithium iron phosphate, you can charge a bucket loads more current. I use a 30 amp hour charger, and you charge right up until it's full. So 14.6 volts, right up until it's full. When it's full, it'll reduce its current, and it'll drop down, the battery charge will drop it down to 13.8. So that's another advantage of the lithium iron phosphate, is you'll charge them at the full rate. You won't have extended charges where you have to delay the charge. Yeah. Sorry to hijack this for a second, but I've got 4 AGM batteries that I accidentally put in storage without any care for a few years, maybe 3 years, and they're not really charging very well.
Yeah,
that's $600, so I'd rather not chuck them right now.
Yeah, there's ways of get on YouTube. I think there's ways of trying to recover, like get some charge out of them. But you really, with lead acid, you should not discharge below 50%. You're really short in their life.
They were just in a situation where I'd fallen out of where I was and stuck them in a cupboard for years,
Yeah.
and now I think they're gone, right?
Yeah, I think so. The lithium iron phosphate,
I say that.
the lithium iron phosphate, you can discharge full, but not the lead acids. Yeah. You don't do that too many times. You might recover them. Some chargers have a like lead acid chargers have like a a restore mode where they try to hit it with more current than that. Look on your charger. Lithium requires different chargers, by the way, usually more expensive, or a charger which does lead acid and lithium profile.
Okay, well, I think it's probably time for a short break.
Okay, it was a little bit more than my, it was a little more on batteries as well,
No,
but
that's good. That
It was very good, actually. Thank you.
Thanks, Greg.
no worries.